Okay guys, just like I promised I would during class, I know we didn't have a chance to get to this problem, so I'm going to go ahead and record the video and hopefully you have time to watch it. So here we go. We started the problem where we had the integration. So we had the integral of 2x over x squared plus 8x plus 20 dx. Alright, we talked about how, if you notice on this problem, you could make this u, and if you take the derivative of this thing, you will get 2x plus 8. Well, notice how you have the 2x there. If we can manipulate this expression so that we can include the plus 8, then we're going to be able to allow this to be u. So let's go ahead and try that. We're going to let u equal x squared plus 8x plus 20. Therefore, du would be 2x plus 8 dx. Well, in order for me to make this replacement, notice how I can make this entire denominator be u. But in order for me to make this change of 2x dx, I need to have a plus 8. So what I'm going to do is in order to include the plus 8, I cannot change the entire expression. So what I'm going to do is I'm going to add 8, but also subtract 8. Because if you add 8 and subtract 8, it's like it was never there, and you haven't changed the expression at all. Well, why would I want to do that? Well, I'm going to pair this together, and now I'm going to rewrite this expression as the integral of 2x plus 8 over x squared plus 8x plus 20 dx minus the integral of 8 over x squared plus 8x plus 20 dx. Alright, now hopefully you see why I would want to do that. I'm going to make some substitutions here where I'm going to say this is 1 over u, and 2x plus 8 dx, I know that that's du, minus, well, I know that this is, I'm going to leave this expression on for the moment actually, so I'm going to leave it alone, and we'll get to it here in just a second. So I'm going to just keep it as it is. Well, hopefully you can see how on the left hand side I'm going to be able to integrate this problem at the moment. So we have the integral of 1 over u. You should recognize that that's going to be the natural log of u. Well, I'm going to go ahead and to save some space, I'm going to go ahead and replace u. Well, I know that u is the absolute value of x squared plus 8x plus 20 plus some constant, right? And eventually I'm going to have to subtract whatever happens here. Well, I look at this thing and I'm like, okay, we had said how I wanted u to be that. So if I wanted u to be x squared plus 8x plus 20, we said that du was 2x plus 8 dx. Well, if I replace that with u, there's no way that I'm going to be able to get a 2x here. There's just no way. I can add and subtract the constant, but I cannot add and subtract a 2x. It's not going to help me. So unfortunately, we're not going to be able to go in this direction. So what I'm going to do is see what happens. First of all, what I'm going to do is I have a constant here, so I'm going to pull out the constant, and then I'm going to have the integral of 1 over x squared plus 8x plus 20 dx. Okay. So here's what I'm going to do. I'm going to complete the square use in the denominator of this expression. And here's what I mean. So I'm going to rewrite everything that I have. Natural log of x squared plus 8x plus 20 plus c minus a times the integral of 1 over. Well, remember that to complete the square on an expression, you would typically leave the first two terms, and you would subtract the 20 and take it to the other side. Well, since there is no other side, it's going to stay on this side. Okay? Alright, so I'm going to keep it on this side so that it stays positive. So now what I'm going to do is, remember that to complete the square, you're going to take the b value here, which is 8, and you're going to divide it by 2. So 8 divided by 2 is 4, and you're going to square it, which makes it a 16, so plus 16. But we cannot change the expression, so in order for us to not change the expression, if I'm adding 16, I also have to be subtracting 16. So notice that 16 minus 16 leaves you with x squared plus 8x plus 20, which was what we originally had. And then you might be asking, well, why would I want to do all this process? Well, let's check out what happens. I'm going to rewrite everything I have. And if I rewrite everything I have, hopefully you can recognize the following. I'm going to have 1 over. First of all, if I kind of group these terms together, hopefully you recognize that the whole point of completing the square is that you can factor this expression out to be x plus 4 squared. And then 20 minus 16 becomes just 4. And when I look at this, I automatically recognize it. But if you don't, let me kind of rewrite it, and hopefully you will. One over 4 plus x plus 4 squared. Well, I look at this thing. Oh, sorry, my dx. I look at this thing, and it almost looks like one of those rules of integration of inverse trigonometric functions. So in case you don't remember, let me turn to the page where I wrote them. Here's what I had before. Look at the one for arctangent. It's like you have the derivative of u over some constant plus u squared. Notice how there's no roots or anything. So when I'm looking at this, I'm like, wait a second. If I let u square equal to x plus 4, means that u would be x plus 4. And then that means that du would be dx. Well, notice how this is the derivative of that. So now I know that this is, I can use arctangent for this. So I'm going to rewrite this for the moment as the natural log of x squared plus 8x plus 20 plus c minus 8, and the integral of 1 over, well, I'm going to let 4 be a square. So a squared equals to a 4, and therefore a equals to 2. So I'm going to say that 4 is a squared plus, we said that, and now we know that du is dx, so du. So we're ready to integrate this thing. Natural log of x squared plus 8x plus 20 plus some constant minus 8 times. Well, now we recognize how this was arctangent, so arctangent of what? Well, remember that the rule says, let me go back to the rule so you can see it. It's not just arctangent, so I made a mistake there. It's 1 over a, times arctangent of u over a plus c. So I forgot the 1 over a, so I need a 1 over, our a value is 2. Arctangent of u, in our case, is x plus 4 over a, which is 2, plus c. And you're pretty much done. You just got to make sure that you kind of clean this up a little bit. We have the natural log of x squared plus 8x plus 20. Now notice how we have this plus c. We're going to have some constant from another constant. You can get rid of one of them and technically just have it at the end. You're going to have plus some constant. So then we have to distribute this in. 8 times a half is going to be negative 4. And then we have the arctangent of x plus 4 over 2 plus that c value. Sorry, it's like way over there, so I'm just going to rewrite it here. Plus c. And we're done. And that's how we would use completing the square to help us out. Okay. Now I understand it's going to be a little difficult to see that from the beginning. It honestly is going to take some practice for you to recognize when you would have to use this method. Okay. Alright, so pause the video if you need to, and then we're going to move on to another example. Alright, hopefully you've paused the video and now you're ready to go for our second example. Now we're going to talk about definite integrals with some of these rules involving inverse trigonometric functions. So here's the problem that I have for you. Let's pretend that we have the integral from 1 to 3 of 1 over x times the square root of 25x squared minus 4 dx. Alright, first of all, we kind of went back to something easier so you can easily recognize it. when I look at this thing, I can right away tell that it's going to be one of those rules that we need to memorize. So if you compare it, we have something with the square root of where we have a square term minus some constant, and then it's being multiplied by something up front. Well, when I compare that to my rules, it kind of reminds me of the secant, where you have some square root of square root of something where it's some term square minus a constant. Then you have multiplied by some term up front, and then you have like the derivative of that u. So I'm thinking I have to use this, but maybe I'm going to start making some u substitutions to make sure I can make it look exactly like this before I start integrating. Okay? So, based on that observation, we can then say that this has to be u squared. Therefore, u squared equals to 25 squared. And we're going to say that a squared equals to 4. Therefore, now, if u squared equals to 25x squared, that means that the would have to be the square root of that, which would be 5x. Okay? Now, remember that every time we get u, if we're going to change everything in terms of u, we need to be able to change that dx into terms of u. So to do that, I'm going to take the derivative of u. So d of u equals to 5 dx. Okay, so when I look at this thing, I'm like, okay, if I start making some substitutions in here, let's see how far along I am. So I have 1, and I don't know what x is, so I'm going to have to leave it alone. And then I have the square root of, well, I know that 25x squared is u squared. And I know that 4 is a squared, so minus a squared. Well, I know that dx is, du is 5 dx, but I don't have a 5, so I can't make that change yet. So I'm like, okay, I was only successful somewhat in replacing things with u and a, but I still have x's left. There's got to be a way where I can bring in a 5 in here. And I need to be able to get rid of that x some way, somehow. So, there's two routes that you can take here. Route number 2 would be, so I can change the expression how it is here to say, you know what? If I need a 5, what if I take the numerator and I multiply it by 5? But remember that if you're going to do something to the numerator of a fraction, you have to do it to the denominator of a fraction. Okay? So at this point I'm like, okay, is that going to help me? Well, now I have 5 dx, and I'm like, well, wait a second. 5 dx would allow me to change this into just du and leave this into a 1. And more importantly, I recognize that this 5x will be u. So I'm actually very satisfied with the decision, because now I have been able to turn everything into terms of u. So now, oh, I'm sorry, don't forget that we were going from 1 to 3. Now I can use that rule that says secant. So it says when I'm integrating this expression, it is going to be 1 over a times the arcsecant of the absolute value of u over a plus c. So this is going to be equal to 1 over, well, what was our a value? Our a value, was 2, so 1 over 2, times the arcsecant of the absolute value of u, which in our case is 5x, all over a, which is 2. Now, because this is a definite integral, that means we have to evaluate this expression from 1 to 3. Okay? Now, as I'm working this problem, I'm thinking that we could have gone back here and changed our restrictions so that we could just use u. But I've already kind of plugged things in here, so I'm just going to stick with what I have here. So I'm just going to plug in numbers. So this becomes 1/2 arcsecant of the absolute value of 5 times 3, which is just 15, over 2, minus 1/2, which is 5 over 2, And with all honesty, if you don't have a calculator, it's not going to get any better than that. I would say that that's the answer. If this happens to be in the calculator section, then I would go ahead and plug that in and find out what it equals to. Other than that, that's all I have for you guys. Please make sure that you study this weekend. I will be posting a list, or either posting it on the hub, or I will send you a message through Remind of every topic that will be covered on this upcoming test. Thank you and have a fantastic weekend.